Okay, Assalamualaikum warahmatullahi wabarakatuh. Saya Nur Zafri bin Abdul Rahim dari Seksyen 1.
Saya Amal Zakur Osman dari Seksyen 1.
Saya Airin bin Azman dari Seksyen 1.
Saya Muhammad bin Saidi dari Seksyen 2.
Nama diberi Iqwan bin Muhammad daripada Seksyen 1.
Okay, for a background project. In Malaysia, the electricity demand increase, especially it's a developing country. These are expected to continue throughout the year. Therefore, needs of stable electricity and were greatly needed due to the industries in Malaysia that requires large amount of electrical energy. It is the responsibility of an engineer to ensure the stability and quality of the power delivered to the consumer. So, these issues are highlighted in this course to give some exposure to the students on understanding the stability of the electric power system and ways to improve the quality of electrical energy stability. The capability of an electric power system for a given original operating condition to recover to a state of operating steadiness after being exposed to a physical disruption like generator outrages, faults, load changes and others, with most of the system variables boarded so that practically the entire system remain undamaged. That is power system analysis. Power system stability can be broadly classified into rotor angle, voltage and frequency stability. Each of these three stabilities can be further classified into large disturbance or small disturbance, short term or long term. Angle stability in power system is the ability of interconnected synchronous machines to remain in step with each other. The rotor angle stability problems involve the study of electromechanical oscillations. The fundamental factor of rotor angle stability is the manner in which power output of a synchronous machine varies with rotor oscillation. The mechanism by which interconnected synchronous machine maintain synchronous with one another is through restoring forces. Time frame or rotor angle stability is that of electromechanical dynamics lasting typically for a few seconds. Rotor angle stability problem can be defined in a different ways depending on the nature and the location of the disturbance in the system in terms of the following two categories. Transient stability depends on both of the initial operating state of the system and the variety of the disturbance. Small signal stability is the ability of power system to maintain synchronism under small disturbance. However, distinguishing between angle stability and voltage stability is important in understanding the underlying causes of the problem in order to develop appropriate design and operating procedures.
Okay, for the scope of project, the power system stability is a simple problem. However, it is impractical to deal with it. Stability of the power system can take different forms, and it is influenced by a wide range of factors. Analysis of stability problems, including identifying essential factors that contribute to instability and devising methods of improving stable operation, is greatly facilitated by classification of stability into appropriate categories, which is 1. Explain the mechanics of stability or instability for a multi-machine power system by accounting for energy of individual machines or group machines. 2. The size of the disturbance considered indicates the most appropriate methods of calculation and prediction of stability. 3. The devices, processes and the time span that must be taken into consideration in order to determine stability. Focuses only 3 cases: study of transient stability of power system using the method of step-by-step solution of the swing curve, equal area criterion, on sudden increase in input equal area criterion for a fault, using programming MATLAB as software for the simulation. For the objective, the main objective of this project is to help students master the process of how to analyze power system faults based on balanced and unbalanced faults techniques. That is why we were assigned to represent the engineer that handle the fault system analysis. We also need to express the power flow analysis using electromagnetic transient program software, which is ETMP software. Lastly, we need to be able to explain the suitable protection schemes to ensure power system delivery and sustainability for the given case study.
New with flowchart. Okay, we starting with start and then meeting with the group members, discuss about the group project, distribute the task among group members, select the bus system that want to be used, and then we find the data sheet from books and other source internet, and we compare the data sheet with the source from others. Okay, then we implant the coding into the MATLAB software. Then we testing the result from MATLAB, whether the system result success or not. If not, we will doing the troubleshoot until the result success, and then we proceed with the final report and then record the video, and the last one is end. Okay, for the flowchart of the project. In order to design a project, the process of setup this project must be according to a prescribed method. The research has been done is based on the main stage of the project, which are doing research and study about the bus system, learning about MATLAB software and others that related. Following are some of the projects outline that is implemented in this project. Okay, for the start the project. At this stage, some important aspect have been taken into account, which is the description of the project, project objective, and project implementation methods to produce. This stage is intended to provide an initial understanding on the projects to be carried out. At this stage, it is very important to determine the direction of the project to be carried out. Okay, we move to the meeting and discuss with other group members. Okay, to make sure members have a good understanding about the focus of projects, some discussion had been carried out. Okay, a project planning has been drafted as a guide to project implementation, so all work can be done systematically. If there were any problems relating to the real direction of this project, we will refer back to the things that have been started before to get a solution. Okay, moreover, we find and select the bus system. Okay, for background study, it is more focusing on writing in the form of a scientific or technical of reading material from books and internet source. It can help to complete this project through theories and existing knowledge. After the background of this project has been done, the knowledge about the bus system can easier for this project. Okay, MATLAB software. This is the most important part and our main method to do the project. We use the coding to implant in the MATLAB to get the result that we needed. Okay, the last one is final report. The last stage for our project flow is about the final report. The final report contains all the information of the project. The result and analysis is also recorded to show the completion of the regulated power supply project. Okay, this is the result of our project. As we can see, this is the 6 bus system rotor speed, and this 6 bus system rotor angle, 11 bus system rotor speed, 11 bus rotor angle.
This is 6 bus system data coding. The phase angle difference of each machine with respect to the slot bus appearing in a tabular form on the screen, which is not present here. The program also obtains a plot of the swing curve which is present in figure 1. Melalui apa yang kami dapat daripada figure 1 ini, pada second 0.4 graf adalah stable, manakala pada phase angle 0.479 second graf menunjukkan imaginary stable. Seterusnya adalah pada second 0.48 graf menunjukkan imaginary unstable. The last figure is figure 4 for phase angle different at 0.5 second. Graf menunjukkan part kedua adalah mengenai rotor angle. Graf diambil pada 0.4 second. Rotor angle. Data diambil pada 0.4 second. Graf menunjukkan stable. Selepas itu, pada 0.479 second, graf adalah imaginary stable. Pada figure 7, 0.48 second, graf adalah imaginary unstable dan last part adalah rotor angle pada 0.5 second yang menunjukkan graf unstable. Last part ialah rotor speed pada 0.4 second. Graf adalah menunjukkan bahawa graf stable. Seterusnya pada 0.47 second, graf menunjukkan imaginary stable. The second last graph at 0.48 second for imaginary unstable. The last graph for bus speed is 0.5 second, yang mana graf menunjukkan unstable.
Okay, I will continue for the 11 bus system data coding. Kat sini kita tengok kita gunakan dalam 6 bus system. Kita gunakan 11 bus sebagai yang kita buat sendiri pada syarikat internet. Kita boleh tengok kat dalam ni. Ni adalah coding-coding dia yang kita gunakan dalam software MATLAB. Lepas tu, with respect to the slack bus, where this is printed in a tabular form on the screen, which is not presented here. The program also obtain a plot of the swing curve, which is presented in the figure 13 below. As we can see, the phase angle difference fault is clear at 0.6 second, and then seeing that the tabular result is printed on the screen. And then the swing curve shown in figure 14 below shows that the machine to phase angle increase without limit. And earlier we get for 0.6 second, but this time for the phase angle difference fault in figure 14 we will get 0.729 second. And then for the figure 15, the phase angle difference of each machine also show that the machine to phase angle increase without limit, but this time the fault is cleared at 0.8 second. The swing curve shown in the figure 16 machine show that the phase angle increase without limit, which when the system is unstable it is cleared at 0.8 second, and when repeated the clearing time is 0.76. They show that the system is not stable. Again, then we make a phase angle difference fault in figure 16. You can see that the phase angle difference for machine 2 is the fault is clear at 0.8 second, and then the program also obtain the swing curve in figure 17. This show that the rotor angle difference is clear at 0.6 second. And then we repeat in figure 18. We found that the fault is clear at 0.729, and then after repeated, the clearing time is decreased to 0.665. The time is decreasing, which it means it is stable, completely stable for the system. And for figure 18, we can see that the rotor angle difference is clear at 0.729 second. This we can see that the rotor angle difference machine with respect to the slack bars are printed in the tabular form on the screen, which is not presented here. The program also attempts a plot of the swing curve, which is presented in figure 19. Again here we can see that in figure 18 the rotor angle difference for clear S0 is at 0.729. At figure 19 the fault clear is at 0.70 seconds, which means that the system is not stable as it should be. When then we plotted the swing curve in figure 20 to show that the machine to rotor angle increase without limit. Thus the system is unstable when fault is cleared at 0.8 seconds. The simulation is repeated for a clearing time of 0.8 seconds. The simulation is repeated for a clearing time of 0.765 seconds, which we can see that it is critically unstable. And then a rotor speed difference for is cleared at 0.6 seconds. The system is found stable when fault is cleared in 0.6 seconds, as we can see in figure 21. Then the swing curve shown in figure 22 shows that machine to rotor speed increase without limit. Thus the system is marginally stable, but when fault is cleared at 0.729 seconds, the simulation is repeated for a clearing time of 665 seconds, which is found to be critically stable. For figure 22, rotor speed difference, fault is cleared at 0.729 seconds. The rotor speed difference which machine with respect to slack bars are printed in a tabular form on the screen, which is not presented. Rotor speed difference with COI reference, see that the fault clear is at 0.73 seconds and then should decrease if it is stable, but the system is found to be marginally unstable when fault is cleared at 0.70 seconds. The swing curve in figure 24 shows that machine to rotor speed increase without limit. Thus the system is unstable when fault is cleared in 0.8 seconds. Transmission is repeated for a clearing time of 0.765 seconds. It's found to be critically unstable.
As the conclusion for this project, where we were asked to represent a group of power system engineers, where the rotor angles stability of each machine in a system. Here, we use a system of 11 buses to complete our project. We had learned on how to do the simulation to find the dynamic response of disturbance in the system in the MATLAB software. We had learned on the ability of a synchronous power system to return to stable condition and maintain its synchronism when there is a relatively large disturbance arising from very general situation like switching on and off of circuit elements or clearing of faults. This is referred as the transient stability in the power system. The truth is, these power generation systems are subjected to fault of this kind, and it is extremely important for power engineers to adapt with the condition of the system to maintain the stability. In general, the practice related to transient stability in power system are done over a very small period of time equal to the time required for one swing. The time for one full swing is usually around 1 second or less. If the system is found to be stable during this first swing, it is assumed that the disturbance will reduce in the subsequent swings. Usually the system will remain stable. Assume that is how the system acts in general. Finally, we can conclude that angle stability and voltage stability related issues are very common. This happens when the value between real power generated and loads are not zero for the angle stability and between the reactive power generated and consumption for voltage stability. Therefore, the needs to achieve the stability can be done by doing the transient stability. That's all. Thank you.